explain firing order. We know that in an ignition system, the distributor passes the spark to each of the spark plug leads one at a time. So we can say that in one revolution, the number of sparks produced by distributor is equal to the number of cylinders in the engine. Now let's consider a 4-cylinder engine. We know that the cylinders get sparked one by one, and each cylinder requires a spark in every 720 degrees of crankshaft revolution. So we can say that a spark takes place in every 180 degrees of crankshaft revolution. The order in which the cylinders are sparked is called firing order. Thus, we can define firing order as the order of sparking in the cylinders of a multi-cylinder engine. Firing order of an engine depends on the number of cylinders in the engine. The power strokes also need to be equally placed to get an equally balanced movement of the crankshaft. The three main factors affecting the firing order are engine vibrations, engine cooling, and development of back pressure. Now, let's try to find out the firing order of the 4-cylinder engine we had considered. Let's consider that the first cylinder is fired. Now the force F acting downwards on this cylinder gives rise to forces in bearings A and B of magnitude F into B by A plus B and F into A by A plus B respectively. Clearly, force in bearing A is greater than the force in bearing B. So, if we fire the second cylinder next, the load on bearing A will increase, which may cause engine vibrations. To reduce this and even out the load, we need to fire the third cylinder now. Also, if we fire cylinders 1 and 2 in succession, half part of the engine will get very heated, which will imbalance the load on cooling systems. To decrease this load, we need to fire the cylinder 3 after cylinder 1. Moreover, firing the first and second cylinders in succession may also result into high pressure in the exhaust pipe, which could initiate the backflow of exhaust gases. However, if we fire the third cylinder after the first cylinder, the exhaust gases will have enough time to leave the engine and would not create pressure in the exhaust pipe. Thus, the possible firing orders for a 4-cylinder engine can be 1, 3, 4, 2 or 1, 2, 4, 3. The firing order 1, 3, 4, 2 is used more commonly. Similarly, for a 6-cylinder engine, the possible firing orders can be 153624, 154623, 124653, and 123654. But the firing order 153624 is most commonly used. The related terms are